Now we talk about the acceleration. Okay, as you know, that acceleration is nothing but you have studied all these things in your ninth standard even. Okay, acceleration is nothing but change in velocity with time. Okay, or we can say time rate of change of velocity. So we can say time rate of change in velocity is called acceleration. Okay, so acceleration is change in velocity per unit time, we can say, or average acceleration, which can be defined as average acceleration is change in velocity divided by time interval. So we can say at time say t1 velocity is v1, and at time say t2 say velocity is v2. Okay, then this average acceleration can be written as change in velocity is v2 minus v1 upon time interval means t2 minus t1. So this is the formula for the average acceleration. We can also write delta v upon delta t. So this is the average acceleration. Now, as you know that the unit of velocity is meter per second and the time is measured in second, so acceleration is having the unit meter per second square. And as you know the dimensional formula, if you want to write, then mass is not measured, L1 t raised to minus 2. Okay, so average acceleration is change in velocity per unit time. Now if you want to find the instantaneous acceleration, then what should be done? Now that is done mathematically. This is the average acceleration. Okay, average acceleration, as you know, a bar, it is written as a bar is equal to delta v upon delta t. Now if you take this delta t tends to 0, that is delta t is very small, then instantaneous acceleration, that is a, is given by taking limit delta t tends to 0, not 0 but tends to 0, means it is very small, delta v upon delta t, and this can be written as symbolically dv by dt. Okay, it is read as dv by dt, time rate of change in velocity. Okay, now this velocity is a vector quantity and acceleration is also a vector quantity, means it has magnitude as well as direction. Now velocity can be changed, or velocity changes when its magnitude changes, that is either value increases or value decreases. So either by increasing the value of velocity or by decreasing the value of velocity, the velocity can be changed. Okay, if you change the direction, changing direction also, the velocity changes. Try to understand when you are moving on a circular path with same speed. Let me tell you, same speed is same. You are keeping your vehicle at 20 km/h and you are moving on a circular path. So at this speed you are moving on a circular path, but you are changing the direction continuously. So we can say velocity is changing as you are changing the direction continuously, because direction changes continuously when you are moving on a circular path, keeping the magnitude same. And by keeping, or we can say by changing the direction and magnitude both simultaneously, when you are in the market you are moving on a zigzag path. Okay, sometimes you are increasing your speed, sometimes you are decreasing your speed, sometimes you are changing the direction, keeping the value of velocity same. Okay, this way you are moving on a zigzag path on a way which is there on the market. Okay, on a marketplace you change your magnitude of velocity, or rather speed you are changing continuously, or you can say you are increasing your velocity, decreasing your velocity, or you can say you are increasing the velocity as well as you are changing the direction, or decreasing the velocity and direction both together, or just changing the direction by keeping the magnitude of velocity same. Barabar? In all these cases the velocity is changing. Okay, and we can say we are in a accelerated motion. Okay, so accelerated motion can be produced by either increasing velocity or by decreasing velocity, or only by just changing the direction, or direction and value of velocity both simultaneously changes, then we can say the object is performing accelerated motion. Okay, now we move further. Okay, there are certain graphs which are there on the page number 46 of our textbook. These graphs are of position versus time. Now you have to just remember for this, because this is the mathematical concept which is generally given in the 12th standard in maths. Okay, that is related to differentiation. Okay, but if there is position versus time graph, now before that you try to understand this. If position is denoted by x, then if you carry out the differentiation with respect to time, then differentiation of position with respect to time gives you instantaneous velocity, that is dx by dt. Now if you differentiate this velocity with respect to time, differentiating velocity with respect to time, that will give you acceleration. So acceleration is dv by dt. So first differentiation of x gives you velocity, and second differentiation of x, as such we have differentiated x only with respect to time first, then we get velocity, and if you differentiate it again, then you get the acceleration. So two times if you differentiate the position, then you will get the acceleration. So sometimes in certain books it is written in this way, that velocity is differentiation of position, and if you take the differentiation of this, which is written as d2x, it is not d square x, d2x by dt2, then this will give you acceleration. So this is a symbol, as such we write it in this way, dv by dt. But sometimes in some books it is written like this, d2x by dt2, then you should understand that it is acceleration. Okay, so these are the symbols. This dx by dt gives you instantaneous velocity, this d2x by dt2 or dv by dt, that gives you instantaneous acceleration. Okay, so these are the things that you should keep in mind. Sometimes this is also denoted in a different way. Okay, in certain books, say x is denoted by position, then velocity is denoted by x dot. X dot means it is dx by dt, and acceleration is denoted by x double dot. Now x double dot is nothing but d2x by dt2. So these are the different symbols that are used in different books. Okay, if you refer them, but right now we have a simple concept that x is position, v is dx by dt, and acceleration is nothing but dv by dt, or sometimes it is written as d2x by dt2. Okay, so these are the things that you should keep in mind, write them in your notebook properly. Okay, now I talk about one graph which is given here on page number 46 of your textbook. Position versus time graph. Okay, now this position versus time graph is, say, this way, that is concave up. To remember this, you can understand it in this way, that it is concave up. This is position versus time graph. If the graph is concave up, then acceleration is positive. This way you remember. Why? Then this will come in your mathematics. If you are learning, if you have a group, that you will learn in mathematics, that if this kind of graph is there, that of one variable with another variable, x versus t, that is position versus time, then if this kind of graph is there, then double derivative d2x by dt2 becomes positive, and double derivative is nothing but here acceleration, so acceleration will become positive. Okay, now if the graph is concave down this way, concave down, then the acceleration is negative. If x versus t graph is concave down, then the acceleration is negative. And if this x versus t graph is a straight line, means the acceleration is not there, or we can say acceleration is zero. If x versus t graph is straight line, you can understand that it is uniform motion. Object travels same distance in same interval of time. If there is an accelerated motion, then different distances are traveled in same interval of time. Here this is uniform motion, so accelerated motion is a non-uniform motion. Here this motion is a uniform motion, means same distances are traveled in same interval of time. Then the graph will be linear graph, that of x versus t, and acceleration will be equal to 0. Okay, these are the things that you should keep in mind. Now we talk about velocity versus time graph. If this is your graph which shows velocity and this shows time, if this graph is straight line, say you have initial velocity v0, and at certain time your velocity becomes, say, v. Okay, then if the velocity time graph is straight line, ascending straight line, you can say this is ascending straight line, then the acceleration is positive. Acceleration is positive means velocity increases with time. Try to understand. As time passes, the velocity increases, means you are increasing the magnitude of your velocity, that is speed is increased, we can say, in our day-to-day life. If accelerator is pressed, then what happens in the vehicle? The speed increases. Okay, so acceleration is positive means here you can say that velocity increases. Okay, this is your positive acceleration. Okay, an object is moving in positive direction with positive acceleration. Okay, so this can be understood from this graph. Okay, now next graph, if you see, then this graph is here this way. Say initial velocity is v0 some value, and after some time its value becomes v, means its value reduces from v0 to v. Final velocity v is less than v0. Okay, as time passes. This is time axis. Okay, so in this the acceleration is negative. Acceleration is negative. A descending line will have negative slope. If you take the slope, try to understand, slope can also be taken. change in y coordinate divided by change in x coordinate. V, that is final, minus initial v0 upon t2 minus t1. Here we can say it is t2. Here it can be taken as t1. Okay. Again I can explain this way. Okay. This is the graph. Okay. Initial velocity is say v0 and the time is say t1. We can say at this particular moment of time. Now after some time this velocity becomes v. So this time, okay, becomes t2. Okay, so value of velocity reduces from this value to this, it has come. Okay, so value reduces as time passes. So this is having negative acceleration. Okay, now if you want to find the acceleration, then we can write v minus v0 upon t2 minus t1, and that will be nothing but difference of y coordinate upon difference of x coordinate, that is slope. So in general we can say if you have the graph of velocity versus time, if you have the graph of velocity versus time, then the slope of this graph will give you acceleration. Okay, if it is a linear graph, here this value from the graph will be found to be negative. So it will be negative acceleration. It means the brakes are applied, means the speed reduces. Okay, in general in our day-to-day life we can say when brakes are applied speed reduces, it means it is negative acceleration or retardation we can say, but motion of the object is in positive x direction. Motion of the object is in positive x direction. Okay, now we talk about the other graph, that is C graph. Here it is in the textbook. Say velocity versus time graph is given. This is time. This is like this. Okay, initial velocity is minus v0 and here it is minus v. When velocity is negative initially, okay, and finally also it is negative, it means that the object is moving in negative x direction. It is moving in negative x direction. Okay, the object is moving in negative direction with negative acceleration. With negative acceleration. Okay, if you find the slope of this, say this is time t1 and this is time t2, then this value will be more negative. It will be more negative and this will be less negative. Okay, so the slope will be negative and you will have negative acceleration. Okay, now if you talk about the graph which is like this, okay, it has initial velocity v0. As time passes the velocity reduces and becomes 0 here. At this point it becomes 0. Say at time t1 it becomes 0. Okay, so velocity is reducing. So an object is moving in first of all positive direction. Positive direction. Okay, with negative acceleration means its velocity reduces, becomes 0, stops for a while and then it changes its direction, or rather we can say it returns back on the same path. Okay, and the value of the acceleration, so from 0 to t1 it moves in positive x direction, and between t1 to t2, say for example this time I consider as t2. Okay, from t1 to t2 it moves in the opposite direction. Okay, so these are the characteristics of velocity versus time graph. Okay, velocity versus time graph will always give you velocity versus time graph is there, and if you find the slope of it, then slope of this velocity versus time graph will give you acceleration. This also you should know. Okay, area under the curve. If you find the area under the curve of this velocity time graph, okay, if you have say velocity versus time graph this way, okay, then area under the graph will give you the displacement. This also you should know. Okay, if you have this velocity versus time graph, then you can understand that it is made up of one triangle. This is the triangle. Okay, and this part is a rectangle. This part is a rectangle. So if you add this area of triangle and area of this rectangle, then addition of these two areas will give you the area under the graph of velocity versus time, and area under the graph of velocity versus time gives displacement. It gives you displacement. So you should know this. These are the different characteristics of velocity versus time graph. Okay. So these are the things that are given on page number 46 as well as on 47. Okay. You just refer them. Okay. There is a note which is given that the x versus t, v versus t and acceleration versus t graphs shown in several figures in this chapter have sharp nicks at some points, implying that the functions are not differentiable at these points. Now these are the things that you should remember just now, because these are the things will come in your mathematics. Okay, in any realistic situation the functions will be differentiable at all points and the graphs will be smooth. So in general the graph is smooth, then it is differentiable. Okay, so these are the some of the situation in which the graphs are smooth. Okay, so we will have those situations only where graphs will be smooth. Okay, the graphs which will be given to you will be smooth only wherever the equation becomes differentiable. Okay, thank you very much. Okay, kinematics equation for uniformly accelerated motion we shall study next time. Okay, thank you.